Всем привет!
Hello dears. Why is the car oversteer? And why is the car turning on a slippery road? I'll try to explain in simple words. The car goes on the road. That is all right. But the road's slippery. And suppose that the speed of our car, for example, 54 miles per hour. We will consider separately the front and rear of the car. You can say this: the nose of the car moves at a speed of 54 miles per hour. The tail of the car moves at the same speed, 54 miles per hour. We unexpectedly drove through the pit. Still, it's normal, just a little shaken. The front wheels of the car received a stronger impact than the rear. What happens from the impact? The nose of the car throws aside and at the same time he still loses speed. Let's say 52 miles an hour. But the tail of the car was with less consequences and speed is not lost. As he moved at 54 miles per hour, and continues to move. And what have we done? The tail of the car goes faster than the nose of the car. He's ahead. The car starts spinning at speed. Here's the simplest explanation of what oversteer is. The tail of the car begins to outrun the front of our car. What can we do in this situation? First, we need to understand what kind of car we are driving. Do we have front or rear wheel drive? Second, we need to know if the car has a stability system. If there is, then further tell there is no sense. You just have to hope or pray that the electronics will do everything for you, and put her on a straight course. If you have not exceeded the permissible safe speed and have not violated the laws of physics, the system of course stability will do everything instead of you. The stability system will straighten the car. It will slow down smoothly some wheels. You will hear light clicks from the brake pedal. What can you do in this situation? You can only work the wheel. But now we will talk about cars that do not have a system of exchange rate stability. As I said, we need to understand what kind of car we have. Front-wheel drive or rear-wheel drive. You will have completely different actions. This applies primarily to the gas pedal. While in the wheel, too, there are differences. Most importantly, in any case not to slow down. It is clear that we were scared and we want to stop. But you can't do that. Can't brake. The car will lose control of this. Your car will start to turn even stronger. You'll leave. It's dangerous. We need to find the strength not to touch the brake pedal. In any case, do not press the brake pedal. So, we remember that the tail of our car moves faster than the front of the car. The tail has a speed of 54 miles per hour, the muzzle of the car 52 miles per hour. The car turns from this. What can we do in this situation? You have a chance if you do not press the brake pedal. If you have a front-wheel drive car, you cannot reduce the speed of the rear wheels. We can't use the brakes. But we can accelerate the rotation of the front wheels. We can influence the front wheels. Add gas engine. The front wheels will spin faster. Therefore, the speed of the muzzle of the car will increase, say to 56 miles per hour. That is, the muzzle of the car will start ahead of the tail of our car. The car will start to straighten up from this on the road. I usually do 1 or 2 sudden presses on the gas pedal. When the car starts to straighten, the gas must be reset. The gas should stay smooth. The way he was before all this. When you are only moving down the road. If you press the gas too long, the car can throw in the opposite direction. You will provoke rhythmic oversteer. In addition, it is necessary to turn the steering wheel at minimum when skidding the front-wheel drive car. Much smaller than a rear-wheel drive car. You have to make a small turn impulse towards the straightening of the car. Sharp and short jerk of the steering wheel. But when the car starts to straighten, you have to put the steering wheel in a straight position, and, to make it in advance, long before the car straightened up on the road. So, the main condition exit from skid marks front-wheel drive car. This add gas. You have to make the nose of the car move faster. Faster than moving the tail of your car. If you drive a rear-wheel drive car, what can you do about it? All drivers turn the steering wheel in the direction of the skid. Students also turn the steering wheel to the right place. Everyone does it right at the beginning of the skid. And then? I'll tell you about it later. What to do with the gas pedal. The engine acts on the rear wheels. If the tail of the car moves faster than the nose of the car, then we have to slow down the tail of the car. It turns out that you have to reduce the gas. The rear wheels will begin to slow down, for example, to 52 miles per hour. If you do not brake the front wheels, the nose of the car will move faster. Hence, the car will start straightening up on the road. If you're still work correctly on the wheel, then you can handle the skid. You can watch the tutorial, which shows how to operate the steering wheel. You must click on the symbol in the upper corner of the screen. Feel free to press. This video will stop while you watch the second video. And what to do if you have a four-wheel drive. In this case, there is no definite answer. There is a four-wheel drive with active front. His work is similar to that of a front-wheel drive car. This car can be straightened during the skid by adding gas. There is a four-wheel drive with an active rear. These cars behave like RWD cars. There is a four-wheel drive with a distribution of 50-50. There are also cars with adjustable torque distribution along the axis. It can be adjusted by solving problems with understeer or oversteer. Such adjustment is necessary for racers. Modern cars are equipped with stability systems. Such systems do not allow to use the techniques that we have shown. In that case, I say, it remains to pray that you have not crossed the laws of physics. They had not been repealed. I mean the coefficient of adhesion. Of course, this factor is affected by the quality of your wheels. But the laws of physics are not infinite. There is a maximum speed for each particular road surface. If you exceed this speed, you will be doomed in case of car skidding. And no electronic helpers will help you. And what are front-wheel drive, rear-wheel drive, and all-wheel drive cars? This will have to be dealt with in more detail. The fact that the average driver understands that an inexperienced driver is not always understood. All the more, if he not was before never. I was asked once, and a rear-wheel drive car is one that has rear wheels turning? And I have heard this question several times. Friends, driven wheels are only the front. The steering wheel only affects the front wheels. The rear wheels have nothing to do with the steering. Look carefully at the cars. But what is a front or rear-wheel drive car? The simplest explanation. Imagine that you have raised your car on the jacks so that the wheels are hanging in the air. Get in the car and start. Try to go. You won't be able to go. But your wheels will spin in the air. If you start to rotate the front wheels, then you have a front-wheel drive car. The rear wheels will not spin in this case. They passively will go behind the front wheels on the road. And if the rear wheels begin to spin, and the front wheels are motionless, then you have a rear-wheel drive car. In this case, the rear wheels push the car, and the front wheels set the direction of movement. When you control the steering wheel, then the front wheels will turn left-right. And if all four wheels begin to rotate as a result of our experiment, then you own a four-wheel drive car. This information may seem too funny, but it is relevant for some drivers.
Но, увы, она актуальна для особо начинающих водителей.